Here is a clone essentially of tixy.land, which is described as creative code golfing. And code golfing is about as far removed from the goals of calculang as you can get. Code golfers don't care about transparency, don't care about being understandable. Code golf is about achieving an outcome with code in the shortest, using the shortest possible code. And it's an art form, and this is definitely an art form because we're going from little functions to interesting and different visualizations. Having cloned this in calculang, then what tools do we have to help us to understand what's happening? So we have, first of all, the visualization of the output, slightly different design, but it's essentially the same thing here. And everything in calculang is like flexible, can be reused. So like we can make multiple different visualizations. This is another one of the same thing, but it just happens to be the same thing because if I select different pieces of formulas and F9, then I see their value here. So what is X? What does it represent? Okay, it represents the position of the dots along the X direction. What is T? And F9, okay, it's like increasing, it's time, it's this. Sometimes it goes backwards because this is alternating. And we can say, for example, this is like 5 times x squared. And we see the different values. It can be hard to read, but we can see that it's increasing. And so what is this function? It's 0.8 times sine of a thing. Sine of a thing, what's the thing? F9. Okay. The thing is t minus square root of something. We know what t is. Now what's the square root? It's the square root of 5 times something squared plus 4 times something squared. F9 that. This looks like a distance formula. The square root of a squared plus b squared, Pythagoras. And if we look at the square root, it's 0 here, and it's like increasing going over here. It's increasing going down here, and it's essentially the distance between a point and 0 with some scaling. But we can see that it's driving these kind of arc shapes. But why do we get red and yellow and red and yellow? Well, we're taking a sine function, and the sine function is bounded between -1 and 1, and it's cyclical. And if we evaluate what's inside it, it's t minus distance, and that translates into a sine result, which has this wave pattern in it. And sine is often used for waves. 0.8 times that. Okay, well, 0.8 times that is just going to scale this down, and we could, for example, check what about 10.8 times that. Everything becomes bigger, apart from odd cases. Right. So we can change the different functions. This one depends on the mouse position. It's a distance 2. Let's evaluate the square root of something. and it's the distance to what? Here. But as I move the mouse, it's different, because it's x minus mouse x squared plus y minus mouse y squared, square rooted. So we're looking at the value of the distance here as opposed to the final result. We can look at whatever it is we want. What is mouse x? F9. It's changing as I move the mouse. There's one here that I really like. So many of these I migrated from tixy.land. So thanks to these guys. And this guy. But this checkered board, whoops, is amazing. Just this code generates this animation. And so how does it work? We know what t is, it's increasing. We know y is the y position here, and x is x position there. So this all looks straightforward enough. So it's like x negative something divided by y plus t animating, moving something. And one ampersand this is a binary operation. But let's evaluate what it does to this result. And that's interesting. It's if we pause and look here, this bitwise operation, what it's doing is categorizing these into 0 or 1. Okay, it's a binary operation, depending on if they're even or odd. So watch these values that are like 3-ish and then 4-ish. Become 1 or 0, depending if they're even or odd. So this function just needs to move between values in an interesting way. Linear something, linear linear. I don't make these things, but I like to try to figure them out. And so we've got a piece of this pattern. So something in the y is causing a partition there as well. So like there's more to this formula, and I haven't fully figured it out, or how to explain it, but that gives us it. And the last little bit is just multiply by y divided by 5. So all that's doing is, remember this is y, it's multiplying by small numbers here and bigger numbers here, which gives you the effect of depth. That's the reason why these balls are smaller than these ones. So let's calculate the whole thing. These numbers are big, those numbers are small. Whereas beforehand, we just had ones and zeros. And so this is using some linearity and some bitwise operations to give this cool checkerboard animation. So thanks to P. Mallon for that function, and hopefully I like this eval on select, because this is something that calculang is deficient at. Calculang, when I speak about it, I talk about transparency, flexibility at the formula level, but this is helping us to go inside the formula and evaluate little bits. But that whole possibility of evaluating little bits safely, etc., is only reasonable because we don't have side effects and we have purity. So the same inputs going into a formula give us predictable outputs. So it's safe to recalculate it as we're trying to figure it out, as we're trying to look at it in different ways, etc. So this is only one tool also. This little environment is a thing, but calculang is independent of this little environment, and perhaps we can use it to experiment with other useful tools to understand what we're looking at.